Good morning, everybody. It's a real honor and a privilege to be here and to kick off such an exciting conference because there's nothing more exciting than what we do. And I think that we're really blessed to live in probably one of the most exciting times in recorded human history in terms of the exponential technologies that are converging to give us the kind of abundance of opportunities in ways that we couldn't even dream of in the past.
In the broadest sense, you might say it does for engineering and manufacturing what the Xerox machine or the word processor or both of those do for the office environment.
Chuck Hall printed the first
3D systems
part exactly this March 30 years ago. He did it because he wanted to help the automotive company, an ailing automotive company in the United States, recover and gain competitive advantage. He was also the first guy to understand the importance of open source, and about 2.5 decades before anybody could utter the word open source, he created the STL file format that remains today the standard connectivity from CAD to 3D printing. And Chuck continued to inspire 3D systems to advance, to innovate, and more recently to democratize in ways that go well beyond price points, in ways that go into simplicity, connectivity, and creating a broad range of products, platforms, solutions, and ecosystems that we believe will converge to improve manufacturing and to relocalize it and distribute it in distributed and meaningful ways, but in ways that will also help kids transform the future by harnessing and unleashing their creativity in new ways. It's also important, as we focus on bright minds, to recognize that this industry today benefited from lots of bright minds. You can see them on the screen. And it's really the journey that Chuck Hall started, and all these incredibly creative and innovative people continue to expand, is the reason why we have this industry. And all of them deserve a big round of applause for the industry that they created for all of us. So as you look at these more influential people on the screen, most influential people on the screen, I want you to remember them because later on I'm going to introduce you to even more influential people. The big deal about 3D printing is that complexity is free. And that's the tipping point, that's the game changer that allows us to begin to think of a future where millions of complex parts that are identical could be manufactured because complexity is free. And also, equally as importantly, we will have the opportunity to mass customize and manufacture millions of one-of-a-kind. Now, I used to think that the Holy Grail was mass customization. I'm learning now from some of my leading customers, particularly in aerospace, that the real Holy Grail for manufacturing is making millions of identical parts with a level of complexity that was never permitted in traditional manufacturing, and with a way that allows us now to gain fuel efficiency, to gain sustainability, and to downward integrate into traditional manufacturing operations like investment casting in ways that unleash completely new freedom in manufacturing.
Where the holes go and what the coating is, that might be the difference in 1 or 2 points of fuel burn in the way a jet engine works, and that's billions of dollars for our customers in terms of performance. Now, the way that's made today is kind of subtractive, right? You get a block of something, and you weld it, and you arc it, and you take the scrap, and it goes someplace, and that's how you make those parts today. And 3D printing allows you to make that product right the first time. It allows you to make it from the core up, so you basically don't have as much waste. The tooling's cheaper, the cycle time's faster, and that is the Holy Grail.
And that is the holy grail, because companies like General Electric are now committing billions of dollars to transition additive manufacturing into a variety of manufacturing activities. And when that begins to happen, when companies like GE and companies like Nike are pledging billions of dollars and are beginning to look into a future where this is fully embedded into their manufacturing strategies and infrastructure, that means that the future is here, and that means that the whole ecosystem will be disrupted in very positive ways, because for the first time there are tangible benefits that would allow for this kind of sponsorship to take hold. And the same is true for automotive. For the same reasons, we're seeing a steady migration of additive manufacturing from the prototyping shop to the manufacturing floor, not just via tooling and bridge manufacturing, but in many instances now outright manufacturing operations, including very demanding under-hood components and parts. For 3D systems in particular, our largest, or not largest, I should say, fastest growing vertical is patient-specific medical devices. It started with all the in-the-ear hearing aids that are now 3D printed. It continued with dental restorations, and it now continues with a variety of full knee and hip replacements, where interestingly, the entire surgical instrument toolkit is patient-specific, is planned for the patient, and is printed, as you can see on the right hand of the screen. Each and every one of those are now printed, sterilized, delivered into the operating theater in a way that substantially improves the outcome of the surgical procedures. Now, many might ask the question, does this technology really scale? Is it cost effective enough? Can you get it to a point where it has the reliability, the uptime, the economy of scale, and the predictability? And my answer is yes. Take a look at what Align Technology did with their Invisalign clear retainers. Last year, they printed more than 17 million unique and distinct patterns to form all of their clear aligners. Each one was unique. It was manufactured in a factory of the future that also mechanized and automated each and every step in the upstream and downstream in a lights-out operation 24/7 with uptime and reliability of over 98.7%. This is what the factory of the future looks like.
In Youngstown, Ohio, a once shuttered warehouse is now a state-of-the-art lab where new workers are mastering the 3D printing that has the potential to revolutionize the way we make almost everything. There's no reason this can't happen in other towns. So tonight, I'm announcing the launch of 3 more of these manufacturing hubs, where businesses will partner with the Department of Defense and Energy to turn regions left behind by globalization.
So politics aside, there are many progressive governments that are beginning to understand the importance of advanced manufacturing in bringing about sustainable, localized, distributed manufacturing back home as a competitive advantage. We see it with China, we see it in Singapore, we see it in the United States, we see it here in the UK, we see it in Germany. Countries are beginning to understand that advanced manufacturing could become a national competitive advantage and a foundation for sustainable and scalable manufacturing economies, which for me is very exciting, because I always believed that manufacturing is cool and that we should try really, really hard to make manufacturing cool and exciting and sexy as part of our next generation. But with that, we also have a responsibility to realize that not all of the amazing things that will come out of this technology are going to be good. So I want to spend a few minutes talking about the unimagined, but also about the unintended, because it's important to be mindful. I happen to think that one of the most sophisticated designs have already been patented by nature. There's nothing more sophisticated than all of us sitting here, we all have incredible intelligence and amazing functionality and capability and utility. And there is a lot that we can learn from nature as we evolve design. And with 3D printing, we think that we could accelerate sophisticated biomimicry in a way that will create superior products in the future. It's a really enabler. And you can see just one example of what the Festo Corporation is doing. I also happen to think, based on our incredible success, that we will have significant advancements in patient-specific medical devices that will go well beyond implants and dental restorations and hearing aid, and we will have a completely new class of devices that will allow amputees to restore their symmetry, that will allow us to deal with a variety of orthotic and orthopedic devices with fashionable, sleek, ventilated, dishwashable devices that will be made for me, that will allow us to deal with fracture bracing in ways that would make it convenient, comfortable, hygienically correct, and extremely effective as you go from swelling to healing. And I happen to think that we will have great parts of the Internet of Things powered and enabled by 3D printing, starting with the work that my dear friend here, Alice Taylor, is doing with Makey Lab, and opening it wide open to dozens, if not hundreds and thousands of new business models that will be launched due to the convergence of infinite computing in the sky, 3D printing, digitizing and sensing, smart mobile devices, and robotic components that will create this abundance of opportunities for entrepreneurs like Alice to launch new products, harnessing the collective capabilities of all of these technologies to reinvent how we experience in a way that's gamified, in a way that allows us to publish, produce, share, and monetize. I also believe that this technology is going to redefine and reinvent merchandising and retailing as we know it. And the reason is because there are opportunities here for the first time to create real immersive experiences that are personalized, that are customized, and the opportunity for the first time to allow millions of people to co-create with their brand, to co-create with the artists that they like, and to make it a real collaborative creative experience. So you can see some of the work that we have done with Disney here in terms of creating for girls princess selfies, for adults inserting somebody into a movie scene, as you can see here with Star Wars, and you can see how it's progressing with stormtroopers, the opportunity to begin to launch movies in a personalized way, and also the beginning of the arrival of real consumer 3D printing onto the retail floor in places like Staples and Home Depot and Asahi Denki in Japan, and scores of others. And I wanted to share this picture with you because somebody sent it to me. This is a picture of Staples in New York. And what was interesting, what was striking for me was to see the two end caps side by side. You can see HP to the left. This is kind of history in 2D, and then you can see, R-Cube 3D printer on the right, which represents the future. Both enjoy the end caps at Staples.
You want to be?
Oh, cool. I made it, Mom. 3
will I look this good on my wedding day? 3D me.
So this convergence of technologies continues to introduce incredible possibilities. And what you see with our 3D Me app is the kind of evolution in photogrammetry that now allows you to upload only 2 pictures and the rest of the magic happens behind the scene. We can now go from a frontal shot and a profile to create your selfie. And I'm happy to make some news here this morning and tell you that Manchester United has given us the exclusive license to begin to create Man United selfies. So if you guys ever aspired to be football players, this is your chance, guys. I don't see any enthusiasm here. No football players in the crowd, huh? Well, if you aspire, if you dream, you can now see yourself as a Manchester United player.
Computers in a very unnatural sort of 2D way. And we're trying to create these 3D objects using a variety of 2D tools. And it doesn't feel natural, it doesn't feel normal the way you should do things. So we started playing around with the idea and using a few of the things that are available out there, such as the Leap Motion and Siemens NX, which is what we used to design the rocket. And we wrote some code to integrate the two. And we started off with what you see here, which is a wireframe of the Merlin rocket engine, and what I can do is I can go and grab it, and I can rotate it in multiple dimensions.
So everybody knows Elon Musk, right? I mean, Tesla and PayPal and SpaceX, and what he's talking about is, how do you begin to harness, how do you begin to converge tools and platforms to make design and manufacturing more intuitive, and to make sure that you create and manufacture on a platform that is actually volumetric, gestural, and integrated. And we like his vision because for the last few years we've been working very hard to integrate things like Leap Motion, like our freeform haptic devices that gives you force feedback, like voxel-based CAD, because we believe that he's absolutely spot on, and that in the next few years there is a real opportunity to reinvent the engineer's desktop in a way that would be intuitive, productive, and eminently manufacturable. I'm passionate about sweets and chocolate, and I have a little skunk works that I run in my free time because I believe that in my role I have to illuminate parts of the future. And so one of my dreams is to create the Keurig analog of a chocolate printer. You can see that on the right. And I also believe in sugar printing because I think it's a way to spread the message. So we acquired the Sugar Lab a few weeks ago as an opportunity for us to begin to expand our reach into food printing in a way that people can relate to it. But make no mistake, although I think that there is an inarticulated covenant of indulgence, in society, the end game here is about printing nutritional foods. It's about personalizing and customizing my nutritional needs in ways that would be good and healthy for me. And this is the beginning of a journey of responsibility and sustainability, albeit starting with fun and attractive and sweet things, which all of us could use a little sweetness in our lives. There's no question in my mind that the convergence of 3D printing, sensing, and fashion is happening. And there's no question that when you add to that wearables, we're going to see real disruption in the next several years, and the whole area of accessories, shoes, belts, and garments, not just as wearables, but also as data collection elements. Think sensors in your shoes. Think mood sensors in other wearables. Think about fitness sensing and health sensing. All of that convergence is going to happen, and it's going to be enabled by 3D printing. And of course, much has been said already about bioprinting and all the opportunities to harness this technology to extend life and to extend it in useful and meaningful ways. Here in the UK in particular, there's been a great deal of research by Loughborough University and other fine institutions to continue to advance fitness, to continue to advance habitat, and there is no question in my mind that the future is going to be bright in both of those areas as they begin to hit commercialization.
Gun that's in the news. It's called the Liberator. It's a now, first of all, I didn't understand the story until I read it like 3 times. And the reason is they used the word printer. There's something called a 3D printer. They should not use that word printer. You think of paper. It's not something that makes paper. They should call it a manufacturer or something. What it is, it's a machine. Boy, they should have this on Star Trek, or they probably do. That you can put in plastic raw materials and it makes something plastic. You can make a doorstop or jewelry or a sex toy, I guess. You know, a 3D object. So, of course, this is America. We made a gun. Duh. Some guy in Texas, of course, Texas, made a gun which he calls the Liberator, and it's plastic. And this caused a lot of consternation because, of course, it would get past any metal detector. Chuck Schumer, a senator, said, now anyone, a terrorist, someone who's mentally ill, a spousal...
So, you know, with all of the unimagined and the unleashed, we're going to have the unintended. And this is only the tip of the spear in terms of the widening gap between exponential technologies that are changing everything at a lightning speed and our societal infrastructure and capacity to cope with everything that is happening. And so we're going to have lots of challenges, in my view, that we're going to have to navigate, and it's going to be our collective responsibility to navigate in terms of, does this democratize counterfeiting? Does it accelerate the unintended migration of IP? Does it allow us to come into illegal possession of items that we couldn't? And you know, the big deal for me with a plastic gun is not that somebody could make it. You know, I'm a pretty good machinist. I could have made a plastic lower case of an AR-15 in my basement 10 years ago and 15 years ago. The big deal about 3D printing is that for the first time, the craftsmanship element is democratized. And that's a game changer when you think about it, that you no longer have to be a craftsman to be able to do all these things. You know, that is a game changer, and it's going to challenge us in good and in not so good ways going forward.
Provides us the ability to be able to do our own Star Trek replication right there on the spot, to help us
so this is made in
replace
space.
things we've lost, replace things we've broken, or replace, or maybe make things that we've thought of that could be useful.
That is going to put the first 3D printer on board.
There are a lot
space
of
station.
hex head 5/32 inch.
And the big deal is that,
on orbit.
you know, unlike other space programs, it didn't start by Boeing or General Electric or Lockheed or Northrop. It started by 3 guys in an incubator because they can and because it's available. So we're going to see a lot of incredible things happening, including my computer crashing. Oh no, it's only the display that's crashing. Okay, we're going to see a lot of incredible things happening, including what Google in Japan just did to allow blind kids on the upper right-hand side of your screen to begin to actually touch and feel, you know, what certain shapes look like, which for me is absolutely mind-blowing when you think about all the good things that our technology can do. So, you know, hands off to Google up there. What does it all mean? It means that we live in exponential times. It means that everything that we think we know is a look in the rear-view mirror. It means that the growth rate in this industry is probably going to be greater than we can imagine. It means that we have a lot of work to do to do it responsibly and to do it correctly and not to get drunk on the possibilities, but actually to make good and do good and deliver a great deal of good. So for 3D systems, that means democratizing access. And democratizing access to me is not just about price points, it's about systematically and passionately removing all of the expert user friction that resides between this technology and the other 99%. It means beginning to think that conferences like this could have hundreds of thousands of people as opposed to a few thousand people, because the language in which we communicate with and from and to each other and with and to our machines is a language that is democratized, a language that is gamified, a language that is on platforms that are meaningful to millions of people, as opposed to the exclusive club that is here today. And it's a language that allows us to do things like this from metal, but at the same time, which you can do on expensive pieces of equipment, but you can do the same thing on a printer that costs maybe $1,000. That is the journey of democratization, and it's a journey that we can't do alone. We need all of you to commit to make it simpler for others to join this exclusive club. Otherwise, we can just expect to have another family reunion with all of us next year, and that's not good enough. So, I want to close by talking about education. I'm absolutely passionate about education because I think that for the first time, we have an opportunity to take 3D printing and make it fundamental to learning every subject matter. This is not just about learning engineering. This is not just about STEM skills or STEM skills. This is about a canvas that can bring to life every subject matter. It can bring to life literature and poetry. It can bring to life mathematics and physics and biology. It can do it in ways that we haven't even imagined before. And kids get it. They don't need a lot of explanation. They get it. They understand it. They are with it. And I can tell you that our job is to make this available to everybody, because we have an opportunity to create a new literacy. We have an opportunity to create peer-to-peer learning, and we have the opportunity to give younger generations tomorrow's competitive skills and tomorrow's competitive advantage today. So I wanted to close with a new picture, with a picture of, come here guys, with a picture of the real most influential people in 3D printing. The most influential people in 3D printing are not the people that I opened with. Those were the people that gave us the foundation, the future of 3D printing, and the most influential people of the future are these guys and all the guys that they represent, because our job is to give them the skills, the platforms, and the tools to create a better future for all of us. So thank you very much, and have a great conference.